I'll be talking about Revolution EDA. Revolution EDA is a project I've been working on for a while. So what is the idea? Why a revolution? Well, basically, chip design industry, chip electronic design automation is the enabling technology of semiconductor industry. It is, if you look at the software, which is basically the up and rising technology for the last 20, 30 years, it used to be semiconductors. Why? Because, well, they have software IDEs and they are extendable. I mean, you know, you will have something like software IDEs like Microsoft Visual Studio. No, nowadays a lot of people are using just Visual Studio Code. Why? Because extendable. It is, a lot of people can contribute to it. This is the model I want to pursue with Revolution EDA, where even the oldest CAD software, AutoCAD, has a EDA marketplace where people can extend it. But when you are looking at the commercial offerings of the EDA software, they are all monolithic. It's just, you know, Cadence has skill, like the others have Tickle, but it is really not, you don't see many people writing for anything for it. Okay. So idea is to democratize IC design, bring in more people, bring in more users, and basically allow people to have a base to build upon. So unfortunately, I had a slightly better presentation. I added some section headers which don't show. So what is Revolution EDA like? It is similar to what people are used to in the last 30 years. I mean, for example, let's name Cadence. I seen it first time 30 years ago and used first time 29 years ago. And a lot of people are used to that flow. I mean, we could have discussions about which one is better, but I mean, that's what I know. So idea is that Revolution EDA has a similar familiar main window. What is the difference? Basically, it includes a Python interpreter. So you could write your Python command here, and although a full API is not yet developed, you could do anything Python can do here. So that is, as I said, it's a Python-based package. There are a few configuration options available that can be accessed through the main window. Also, it gives an error messages and also writes the same error messages to error warning messages to a log file. It has a familiar library browser interface so that people can, you know, you can, a lot of people are used to that type of interface where you could open your symbols, schematic, config views, maybe Verilog A view, and so on. And library paths are also defined under the library menu. There's the library path editors. And libraries are actually nothing specific about libraries. They are a bunch of folders with some JSON files in it. So all the design format is text-based. So design entry tools at the moment is what is robust is, maybe I should qualify it, is a schematic and symbol editors. I mean, robustness is, of course, is on the eye of beholder. And so we are working on some other tools like layout editor and simulation GUI cockpit. So we do have a symbol editor. Actually, whole design starts from the symbol for if you are doing a classical customizing design, and symbols is where you capture all the intelligence behind the device models and everything. Basically, there are different kinds of labels. Some labels are just text, and some labels are a little bit more intelligent, what's called NLP labels. And then you will have Python labels, which allows you to access a Python function defined in the PDK. Why is it important? Because then you could define all the second-order parameters, geometry-dependent parameters in PDK inside symbol. I mean, Symbol Editor has all the basic functionality you will need to use to create symbols, pins, labels, lines, circles, rectangles, arcs. I haven't implemented the polylines, but this is not something that's used that often. Schematic Editor is, again, should feel familiar to the experienced users. A symbol can be generated for a schematic automatically. Some instant labels for that symbol are generated automatically. It will, of course, is fluid. You can change it as needed. And then you could add file labels as needed if you need some extra functionality, as long as you define them. Net editing is another thing, is actually something people have very high expectations. And actually, I thought it would be a simpler question to do a good net editing, but not easy, actually. But at the moment, we could name nets, merge nets, snap to instant pins, snap to other net endpoints, and global nets can be defined. So let's say that if you define the ground instance, ground symbol with a pin which has an exclamation mark at the end, that will carry to all the net connected to it. Basically, you can go up and down the hierarchy, and you could, again, change the instant properties with the familiar dialog. And for example, let's say that in this case, you included instance, endmost length, width, number of fingers, and AS will be automatically calculated, in this case 561. Don't pay too much attention to that. So you could have a netlist line defined. These are instant attributes, actually can't be changed at instance. They are just there for information purpose. So sort of you could think as attributes as like in Python or any other software, like the class property, class attributes, while labels are per instance changeable parameters. That is something requested by some users, and because they are used to it, basically, if you are doing a design, you won't have always some schematic. Maybe you have a schematic, or you want to design a block in Verilog A, or you want to basically maybe extract a netlist. So you want to be able to use per particular cell that representation of design data. This allows it. Basically, there are two ways of doing that. You could have a switch view list. You can do that as well. Or you can create a config view with a config view editor so that it will be using that representation in the netlisting. So you can, at the moment, import Verilog A models, and it will create a symbol. And when you create the netlist, all the information will be there. This is a preparation for creating a simulation GUI. At the moment, it is, if you see, it is really geared towards Zeiss, because in earlier incarnation with the Glade, I done some Zeiss GUI. But that could be done with ngSpice. I dabbled with the OpenVAF a bit, but didn't have too much time to really have a test drive. So netlisting is hierarchical. Again, config view based or switch view list based. It can be selected from the schematic relevant dialog. File label values will be carried to netlist. If you see here, there's a calculated value. So if you want any modeling, the backend could be as complex as you want, as long as somewhere you have something that generates this number. It's not that complex, but full power of Python could be used. Netlisting is, as I said, still being worked on because it is really it is really geared towards size, but ngSpice support is planned as well. Okay, this is how we support to PDKs at the moment. It is really a very basic example of how you would write. So you would have a class for the device, let's say, in this case an MMOS, and you will define some method for that, in this case AS parameter. So your, as long as your symbol name corresponds to that MMOS, whatever class name, that will just go and find the relevant function. So you will have all the, maybe that class, all the relevant parameters here, and then you will be able to calculate your second order parameters, whatever there in the function. So this is not really too important because it's easy to do with it because we are using Toolkit. So that's, we are using Qt6, so it's quite easy. You can create, print, PDF, PNG, whatever. This is something because I started to think about, and it's very early. This is one of the focus points is maybe do a layout editor and use a Python library for export. Then I would think that a schematic-driven layout would be possible. The other thrust of development work hereafter would be about simulation GUI. Initially, I had created a simulation GUI to run on Glade using its embedded Python editor, but now we are pulling it to that work. Of course, Toolkit change and everything to Revolution EDA. So that will have, the idea is that you will have a point and click interface. You will be able to point a net or schematic, instance pin and draw the currents, draw the voltages. And actually not only that, because I see that mistake quite a bit where people assume that analog designers just do some divination by looking at the plots. Actually, we don't care about if it is sinusoid. We care about harmonic distortion or the third order intermodulation product and so on. So all these will be included in that, and bandwidth and so on. And idea is to create an API so users can implement functions they need. So at the moment, what does Revolution EDA need? Am I running out of time? Actually, no, it's good. It's good, I'm going fast. So I don't want, because I'm the last speaker, I don't want people to totally fall asleep. So we need fully fledged PDK. Of course, that PDK means symbols, instance callback, parametric cells, or if we do the layout, and device models, well-defined device models. And of course, it needs testing. I am not a software engineer, I'm a chip designer who is pretending to be a software guy, so I don't have much tests written. For me, it's really working. I do a few things, it works, but this is not how it's done. There must be more tests. We need user tests, and we need, of course, silicon never lies. We need the silicon done using this flow. Okay, so it is buggy, but some well-known software is buggy as well, but you are paying a lot for this bugginess. And I would love to get any ideas for development or anything any suggestions. As I said, like config editor was a suggestion by one user saying that, well, without that, they wouldn't touch it. This is it, was it too fast?